Let's go inside the folder named Large Batch Optimizer. In this demo, we will try to train our models with large batch optimizers such as LAM and LARS. I believe most machine learning developers and researchers have tried data parallel training when developing their models. Adam is the most commonly used optimizer for data parallel training. However, Adam does not scale to a very large batch size, leading to poor performance. In these cases, we have to use large batch optimizers such as LAM and LARS. Colossal-AI has built-in support for these optimizers. As you can see, there are two files used for Colossal-AI training. The first one is config.py, and the second one is train.py. Config.py defines the training hyperparameters such as learning rate, and also the features that we want to inject into the training process, such as mixed precision training. The other file, train.py, defines the common training workflow. We can directly import LAM and LARS from Colossal-AI. In the main function, we define an argument called optimizer to choose between LARS and LAM. Afterwards, we can just launch the distributed environment with Colossal-AI. Next, we just need to create the large batch optimizer depending on the argument. Finally, we just call Colossal-AI.initialize to inject features such as mixed precision training into our training components. The training loop is just similar to how you will write it with normal PyTorch. Next, we will install the dependencies defined in the requirements.txt file. Once the installation is done, we can use Colossal-AI run to launch multiple process training. We define mproc per node as 4 so that we will use 4 GPUs on this node. Remember to provide the file name for the configuration file and also the type of optimizers that we want to use. Firstly, let's try LARS. As you can see, Colossal-AI has initialized the distributed environment and started training. When LARS is used, Colossal-AI will build a high-performance fused kernel for parameter update during runtime. The kernel build will only be executed when it is actually required by the program and only triggered once. Afterwards, the training will officially start as shown by the progress bar. As this is only a demo, we will only train for 20 steps. Next, we can change the argument optimizer from LARS to LAM to try with LAM again. As kernel build has been executed in the previous run, it will not be triggered this time. As of now, we have demonstrated data parallel training with large batch optimizers such as LAM and LARS in Colossal-AI.